In this video, we'll continue our discussion, finish it up, of section 2.3 linear equations. We're going to solve a diffie an IVP, but we want our answer to be in terms of an integral defined function. So what that means is kind of like the last video, we just don't use the error function. We're just going to use a normal integral. So first things first, let's put it in normal form. Y, and then dividing over here, I got a nice pretty X. So this is first order linear, so e to the negative square root of 1 over x squared. Let's go ahead and make that. I know I got to do an integral, so x to the negative 2 dx. That's e, I got to go up by 1, so that's negative 1, divide by the new one, so I just get a 1 over x. All right, it's not pretty, but we can work with it. D dx is times, it's e to the 1 over x times the independent, which is y. Remember, that's our whole product rule. That's the point of mu. And then I have to multiply both sides by this. Now, you may be tempted right away to jump to, I guess you could probably use integration by parts if you wanted to calculate that thing, but they don't want us to. I think actually integration by parts is going to cause maybe an issue. Yes, integration by parts is not going to work here because that 1 over x. Maybe it will, you can give it a shot, but looking at it first glance, I don't think it will. So what we're going to do instead is I'm going to go ahead and take the integral. So we get the integral, and now I'm going to change it to terms of t. Remember, I get the first bottom number from here. So 1 to x, and then I change these to a different variable, dt. You could pick any variable you want there. It's what we call dummy character, because as soon as I take the integral, that character goes away, right? And then we like to put our plus c outside of that. Okay, so I have that, and now we have to find c. They gave us y of 1 equals 0. So if I put 1, okay, on the right side, I get e times 0. And then this is going to be from 1 to 1 dt plus c. Well, that's 0 as well, so c is 0. Okay, so then we get e to the 1 over x times y equals 1 to x of t e to the 1 over t dt. And then now I can solve for y, and it'll be in the right term. So y equals, and I'm just going to put this out front, it can't go in, 1x t e to the 1 over t dt. You could use anything you want for that t. All right, and that is our final answer. So the whole point of that is maybe the integral, I want a function, but the integral isn't pretty, right? It will work, right? We'll have something from 1 to x. But this would allow us maybe to put it in a computer and let a numerical process do the integral for us. It depends where this is going to go. All right, that's section 2.3. Tons and tons of linear, first order linear. Please get this down, and the separable stuff. It's probably the most important because going forward, we're going to be taking a bunch of diffie q's, doing something to them, and turning them into a first order linear separable equation.